All right, let's take a look at letters F and G. Now we're going to create quadratic equations using roots that are opposite. So the first one is x minus 3, or sorry, x equals 3 and x plus 3, maybe if my computer wakes up. So the factors are going to be x plus 3 and x minus 3. And when I put those in the box, x minus 3, x plus 3, x squared plus 3x minus 9, what happens in this case? Those two middle terms are opposites. Positive 3x and negative 3x cancel, and I'm left with x squared minus 9. Now, is that going to happen in G also? So, x plus 4, x minus 4, what is the equation? X squared minus 16. So, in H, it asks, what is the middle term of each quadratic? What is the middle term here, the x term? It's actually 0x, right? So, why is the last sign in this case negative? The factors or the roots have different signs. So we're going to use the box to factor each quadratic you created above. So I'm going to start with x squared minus 9. So I put x squared here and negative 9 there. What's the next step? Multiply them together. X squared and negative 9 make negative 9x squared. So I'm looking for the factors of negative 9x squared that add to be what? 0x. Are there factors of negative 9 that add to be 0? 3 and negative 3. So this would be 3x and negative 3x. I'd pull an x out of this. X times what is x squared? X times what is 3x? X times what is negative 3x? Negative 3. So I have factors x minus 3 and x plus 3. How do I find the roots? Set them both equal to 0. And I get x equals 3 and negative 3. Okay? Now, these have special names. Whenever you have like x squared minus 9 or x squared minus 16, these are called a difference of perfect squares. Some people refer to it as a Dopp's quadratic. Why do you suppose they're called difference of perfect squares? They're what? They're perfect square. You can square root both of them. Is there something to the second power that equals x squared? X. Is there something to the second power that equals 9? 3. Okay? And there's a subtraction in the middle. Would this work if that subtraction was not a subtraction, but it was a positive 9? Why not? So if I had x squared plus 9, so why does this not factor? Right. There's no way to cancel the x's and have a positive n term. Because my choices are 3x and 3x. Is 3x times 3x, sorry, is 3 times 3 9? Yes. Does 3x and 3x cancel to 0x? No. What if I make them both negative? It's still a positive 9. Well, what if I make 1 plus and 1 minus? Now it's no longer a positive 9. So this only works if you have something to the second minus something to the second. So if I had something like x squared minus 400, could I factor that? Well, is x squared a perfect square? Yes. Is 400 a perfect square? Yes. So this would be what? I don't even need to draw the box. What are the factors? X minus 20 and x plus 20. Does that make sense? Okay, what if I had x squared minus 7? Is that going to factor? Is 7 a perfect square? No, you could say x minus the square root of 7 and x plus the square root of 7. Yeah. So it kind of factors, but not into any sort of nice parabola, not in any sort of nice fashion. So the remainder of these, you're just going to find the roots using the factors. And on number 9, what are the factors going to be? X minus 1 and x plus 1. What are the roots? Set them equal to 0, move them over, and I get x equals 1 and negative 1. And if you want to, you can write it as plus or minus 1. Okay, those are pretty easy. Now turn to the last page. What happens if the quadratic is a little more complicated? So what's different about this top equation that we haven't dealt with yet? There's a 3 in front of that x squared. That is referred to as a leading coefficient. Coefficients are those numbers in front of the x's. The first one is the most important one, and it's called the leading coefficient. So I'm going to draw the box, and it works the same way, but if there's a leading coefficient, your answer, at least one of your answers is going to be a fraction, unless we can divide it out. So it works the same way. We put in 3x squared, and we put in negative 6. What's the next step? Multiply those together. Negative 18x squared. Now I'm looking for the factors of negative 18 that add to be negative 7. If that 18 is negative, what do I know about my answers? One's negative and one's positive, and more importantly, the bigger one is negative. So I go through the factors of 18. 1 and 18, does that work? No. 2 and 9, does that work? Yes. So which one gets the negative? So I'll put 2x, well, let's put 9x there. Sorry, I want to put 9x, negative 9x here, and 2x there. Now this gets a little bit more tricky, but it's the same idea. What does the top row share? A 3x. Does everybody see that? 3 goes into 3 and into 9. And x goes into x squared and into x. If all you did was pull out an x, it's not going to work in the end. And I'll show you that in a second. So I can pull out a 3 and an x. 3x do they both have an x squared? Sorry, I don't know what you mean. Okay, so 3x times what is x squared? X. 3x times what is negative 9x? Negative 3. And x times what is 2x? 2. So my factors are x minus 3 and 3x plus 2. This first one is easy. Set it equal to 0. What's the root? 3. The next one is a little bit harder, but it's not too bad. If I set this equal to 0, how do I solve for x? Not yet. Right, so I need to subtract 2 and then divide by 3. Does that make sense? Why you have to do it in that order? So subtract 2, then divide by 3, so negative 2/3. So if you have a leading coefficient, at least one of your answers is going to be a fraction. Now let me show you what happens if you don't pull out that 3. So let's say I look at the top and say, okay, these share an x. X times what is 3x? 3x. X times what is negative 9x? Negative 9. What times 3x is 2x? There isn't one. So if that happens, you must have messed up. And then you go back and look, oh, these also share a 3. Okay? So let's do number 13 together. I draw the box. 2x squared and 4. Multiply those together. 8x squared. Are there factors of 8x squared that add to be negative 9x? Negative 1x and negative 9x. Okay? So, what does the top row share? Just an x. X times what is 2x squared? 2x. X times what is negative 1x? 2x times what is negative 9x? Oh, sorry, that's supposed to be an 8. Yeah, that doesn't work. So 2x times what is negative 8x? Negative 4. So what is my root here? X equals 4 is the first one. And then here, if I set this equal to 0, I add the 1, and then I divide by 2, so I get 1/2. Does that make sense? And trust me, the way I learned how to do this when I was your age was much, much, much harder. Essentially, you just kept guessing until you got it right. So, if this seems a little clumsy to you, it's way better than the way we used to do things. All right, number 14. Draw the box. 6x squared and positive 6. Multiply those together. 36x squared. Are there factors of 36 that add to be 15? 3 and 12. So 12x, 3x. What does the top row share? 6x. 6x times what is 6x squared? And then 6x times what is 12x? 2 plus 2. And then this would be a 3. And then I can double check, is 3 times 2 6? Yes. So what is this root here? X equals negative 2. And the other root, we subtract the 3, and divide the 6, we get negative 1/2. Okay? Could I have made this problem easier to begin with? Well, if you look at these, do those share any numbers? We could divide by 3. If I divided by 3, then I would get 2x squared plus 5x plus 2. And that would make this number smaller. And actually, when you finish it out, this would be 2 and this would be 1. And you're still going to get negative 1/2. So if you look at the original problem and you say, oh, they all have a greatest common factor of 3, then you can divide that number out and then just solve it. Okay? All right, your assignment today is to finish the rest of that worksheet. Good luck.